We have seen parallel resistances, series resistances, but now we will talk about something different, which is arrangement of three resistances, which can be said as delta or pi depending on their arrangement. So this is called delta arrangement because of the shape. Of course, there are three resistances here connected, RA, RB and RC, and they are connected like a delta. Sometimes it's called also pi arrangement because these two essentially are the same. So it's called pi because it's shaped like a pi. uh, Pi means the mathematical pi, not the food, of course. And so that's one kind of arrangement, and we can convert this. Sometimes this kind of arrangement is not convenient for circuit solving, so what we do is we convert them into a different kind of arrangement, which is something like this. Here what we can see, all the three terminals are accessible. So this is called pi, sorry, this is called Y because it looks like Y, and these two again essentially are the same, and this is called T arrangement because it looks like T. So basically if this one goes above a little bit, Y and T are sort of similar, so basically they are just different names. So these two are the same, and this is converted to this or this. So that's what we will do. We will try to derive the conversation for this problem from delta to pi. So we will focus on delta to y, sorry, not pi, because delta and pi are essentially the same as we said. So when we start, we have to notice first that there are three terminals, and where our terminals cannot change. Here they are shaped like delta, and in this one there will be like y. If we can say it's like pi, and it will be here like t, whatever. So terminals are important, we cannot change the terminals. So if we want to find R, what is seen from here and here, so basically RAB, sorry, RAC, if in delta, that will be equal to these two are in series, RA and RC are in series, and then parallel with RB. So if someone is seeing from here, or a source is basically looking from that direction, that means if a source is set here, what the source will experience as the resistance. That's what we say when we say looking from this side. Basically, what the resistance the source is seeing or experiencing. So that will be these two in series parallel with this one. So we can write RB parallel RC plus RA because these two are in series, and then all three sum because that's how it is. So I will just write like that. That is for delta. And for y, if we like to find, so basically we are trying to substitute the value of R1, we are trying to find the value of R1, R2 and R3 in terms of these values, because we are substituting this kind of arrangement to this kind of arrangement. So we are basically changing the arrangement from y to delta, and what will be the change resistance values, that's what we want to find basically. So if we see from here, that is essentially RA and R3, sorry, R1 and R3 just in series. So R1 plus R3, that is from Y, and we are trying to say that we will find the value of R1 and R3 so that RAC, basically seeing we can see the same resistance, or the source will experience the same resistance. So these values we know, we have to find the values of R1 and R2 and R3 so that we can change the arrangement like this one, like Y or T, whatever. So that's there. Now we can say what is the value of RAB, which will be, again, if we look from here, that will be, we can see that RB plus RA plus RB, these two are in series, and RC, those two series parallel with RC. So RC parallel RA plus RB divided by sum of all three, because this one sum this two, so that will be just sum of all three. So that is for delta. and for y will be, this is for delta basically, and y will be, if RAB is seen here, that will be R1 plus R2, which is obvious. R1 plus R2. So that is RAB. Now we just the thing that's left is RBC. So that one will be resistance seen from here. If there is a, it's becoming clumsy again. So I will probably erase these ones. So that's RA here. And that's resistance RA here. So something, if was connected from here, we could say that this one, these two in series parallel with RA. So RA, we can see there is a symmetry, so that helps. RB plus RC, because RA parallel with RB and RC series, that is in delta, and in Y will be of course R2 plus R3, because seeing from here RBC, R2 plus R3, R2 plus R3. We can see we have three equations here and three unknowns, R1, R2, R3. We have to find those three unknowns in terms of RA, RB, RC. So we can forget about this thing because these are the same. So these three, these are our equations, these three. And what I can do, I can subtract, if I call this equation 3 and if I call this equation 2 and this one 1. So I can do 1 minus 3, which will give me R1 plus R3 minus R2 minus R3. So that will be R1 minus R2. And that will be, so here we will have, the denominator will be the same, RA, RB, RC, because they are the same. So we have to just subtract the numerator of this one of this one from that one basically. So RB RC plus RB RB minus RB minus RC minus RC basically. I know these are pretty bad handwriting, but that's how I can manage. So these two getting cancelled, so R1 minus R2 is becoming again RBRC minus RARC. So if I take C as common, it will be RB minus RA, and here we have the same thing. So we can call this equation 4. So now what we can do, we can see here that our equation 2 and equation 4, if we add them, R2, here we have R1 plus R2 and here we have R1 minus R2, so R2 gets cancelled. So if we add them, equation 2 plus equation 4, that will give us 2R1, and in the denominator will be the same again, so the addition becomes easier. And all we have to do is we have to add the numerators. So RA times RC plus RB RC, and this one is becoming RBRC. We have to add them, so RBRC plus RARC, RBRC minus RARC, because we are adding now, not subtracting. So these two getting cancelled, and we have 2 here, and we get 2 RBRC on the other side. So 2R1 here and 2 RBRC, and this is RA plus RB plus RC. So I can get rid of the 2 here. So 2 erased. So what we are getting is R1 equals to RB times RC divided by RA plus RB plus RC. So I won't go into finding the other two because we will see that there is a symmetry. I will redraw them probably here. So, or maybe I will just go back to the original picture. We can see that this is A, B and C, and so maybe I will redraw. So yep, so A, B and C here. So this was the arrangement here, and we know that this is our RA, opposite of A, this is our RB, and this is our RC. And when we convert it into Y, that was like this. A, B and C. So we had, we'll just double check here. So R1, R2 and R3, R1, R2 and R3, and we have just found out that what we got is for R1 which is this one, which is so this is our node here, sorry, this is our node C here. So R1 which is connected to A, there we have here RB times RC, both the two resistances that are connected to A, those two are multiplied in the numerator, and in the denominator sum of all three. So R1 equals to RB RC, RA plus RB plus RC. That's what we got. And if we do the manipulation, equation manipulation here, so basically if we substitute R1, value of R1 into one of the equations, 1 or 3, we will get the other two, of course. So I won't go there, but we can see that there will be a symmetry. We will see there is a symmetry. So R2 will be, R2 is the resistance in Y which is connected to node B. So here what two resistances are connected to node B? RC and RA. So that will be RA times RC, and in the denominator will be the same, RC. And R3 will be, R3 is the resistance that is connected to node 3 in Y connection. So here RA and RB, in delta connection RA and RB is connected to node 3, because in delta at each node two resistances are connected, while in Y only one resistance is connected. So we are trying to find for any node that resistance in Y in terms of delta, two resistance of delta. And so this is very easy to remember actually, because this is R3 connected to C. What two resistances are connected to C here? RA and RB. So RA and RB. Of course, when we will do problems, we won't have to write all these RB and RC. We will just try to remember it this way, that for this one, whatever resistance we are trying to write here, find the value of that will be equal to what two resistances are connected at that node in delta connection, those two multiplied divided by sum of all three resistances. So that's how we have to do it. So this is just how to convert from delta connection to Y connection. I just wanted to show, but these are the results that we will often need, and similarly we will try to do Y to delta connection as well in the next problem, probably next video probably. So yeah, thank you.